Okay, so this video is going to try and go through the general solutions for cosine and sine. Now, if there's a restricted domain, then there's a finite number of solutions. So for example, if you have 2 times sine 4x is 1, and the restricted domain is x is between 0 and pi, you can solve that. And what does that look like visually? Well, you have your sine graph with a period of pi and 2, which is given by 2 pi divided by 4. And you have 2 full cycles there, so one revolution, another revolution. Now if I plot the line y equals 1, that's the line y equals 1, you see you have 1, 2, 3, 4 solutions. So this is basically, y equals 2 times sine 4x, which is the red, and y equals 1. So where do they equal each other? It's where they intersect. And the way you would do that algebraically is you'd go, okay, equate them, 2 sine 4x is 1, and then use your special angles. Okay, so divide both sides by 2, sine 4x is a half. And I should know, using my special triangles, that 1, 2, root 3, this angle here is 60 degrees or pi and 3 radians, and this is pi and 6 or 30 degrees. So 4x being a half, sine 4x being a half, the angle being 4x, opposite and hypotenuse, so 1/2, so this is the angle I'm looking at, pi and 6 or 30 degrees. So 4 and x has to be pi and 6, okay? And then what have they done now? Well, they've divided everything by 4, and they get pi and 24. And then to get the other solutions, they just add the period, okay? Because to get from this pi and 24 to the next one, I have to go all the way around one full period, and from there to there, that is a period of pi and 2. So you can just add pi and 2 to pi and 24. That was using the base angle, yeah? But you also have the other solution here, 5 pi and 24. So how do you get that one? Well, we should know how to use cast, okay? So C-A-S-T, and you have, 4x is a half, and the angle of sine 4x is a half. This is positive a half. Where is sine positive? It's in this quadrant or this quadrant. So the first one would be positive pi and 6, and the other one would be pi minus pi and 6, which is 5 pi and 6. So they've done it slightly differently here. I would have gone, in this step, I would have gone 4x is pi and 6, or in this quadrant, pi minus pi and 6, which is 5 pi and 6, and so on. And then divide everything by 4, and then add the period of pi and 2. So you get x is pi on 24 or 5 pi on 24. And then you can start adding the period of pi and 2 to get, your solutions. So again, just repeating, pi on 24 is the first solution. You go one full cycle from that point to that point is the length of pi and 2. So pi and 24 plus pi and 2 gives you that one. The other one in this quadrant was 5 pi and 24. You then have to add another 2 pi to get another pi and 2 to get that 17 pi and 4. And if you're not sure how that works, you can go 5 pi and 24 plus pi and 2, which is the period. Create a common denominator. It's going to be 5 pi and 24 plus, to get a base of 24 here, or a denominator of 24, I need to times by 12 on 12. So it's 12 pi on 24 24. 5 pi and 24 plus 12 pi and 24 is 17 pi and 24. Okay, so that's with the restricted domain. But what happens if there's no restricted domain? You know, how many solutions are there? There's actually an infinite number of solutions. Yeah, your sine graph looks like this, and it goes the other way as well. Bit funny there, sorry. And then you have, you know, a line that goes through. So there's an infinite number of solutions, and we can work out how to do these with these general solution formula. Okay, so for cosine x we have the general solutions given by this formula, and for tan x the general solution is given by this formula, and for sine x general solution is given by this guy or that guy. So you've got two things there, and we're going to try and sort of derive these. So here's a visual of cos x equaling 0.5. So visually, y 0.5 is the black, y equals cos x is the red, and you know there's no restriction, so it would keep on going forever in that direction, keep on going forever in that direction. There's going to be an infinite number of solutions. So how do we get that formula? Well, what we can do is the following. Okay, so what I'm going to try and do is show you how it works with, you know, what we already know. So we know stuff about special angles. Okay, I know that if cosine x is positive a half, then it is given by pi on 3, or in this quadrant cosine is positive, but also in this quadrant cosine is positive. So cosine of pi on 3 will give me a half, and cosine of negative pi on 3 will also give me a half. And then what we need to do is use the idea of the periodic behavior of sine and cosine functions, so how they start repeating themselves. So if I know that if I go up pi on 3, right, and I get cosine pi on 3 equaling a half, then I also know that if I add a multiple of 2 pi, I can get back to the same point, and it just keeps on going. You add another multiple of 2 pi, you can get back to the same point. And it would also work if you're going back in the negative direction. Okay, go back in the negative direction. If you minus 2 pi, you can get back to the same point. So from my special angles and my knowledge of the unit circle and how things are periodic and repeat, I know the following. I know that x is positive pi on 3 or minus pi on 3. Okay, so the minus pi on 3 is going in that direction. And I also know that in order to get back to this point, I can add multiples of 2 pi. So I could just add some multiple of 2 pi to this one, or add, or even subtract, you know, plus or minus 2 pi, some multiple to that one. So let's just call the whole number thing n, alright? So if n is 1, I'm just, you know, going around 1 full revolution, so 2 pi. If n is 2, I'm going around 2 full revolutions, or 4 pi. So what does the general formula say? Well, it says that cosine x being a half, the general solution says I get my x value by going, you know, multiples of 2 pi plus or minus the inverse of 0.5. And I should know from year 10 maths that, you know, to get x by itself, what you do is you normally take the inverse. So if you had, you know, cos of theta equals 0.3 and you want to find the angle, what you would do is you would take the inverse, all right, using the calculator. We've just been dealing with special values. So more generally with the 0.5, I know that we have inverse cos of 0.5, or the exact value thing is this x is pi and 3 or x is minus pi and 3. So you get the plus minus pi and 3. Okay? And then we might have to create a common denominator. So I could rewrite this as multiplying the top and bottom by 3 as 6n pi on 3 plus or minus pi on 3. Okay, and then I could even more generally take out a pi there, and you would get pi of 6n plus or minus 1 on 3 as your general solution for cosine x equals a half, or 0.5. Now n is a integer, alright? N is a positive or negative whole number, and that's from that idea of, you know, just going around a full revolution in the positive or negative direction to get back to the same point. So that's the formula for general formula for cosine. I think I'll leave for another video the general equation for, or the general equations for sine. So that's it.